Hi everyone, welcome to the NVIDIA GTC Studio. My name is Tiffany Jansen, and today I am joined with a very special guest, Scott Armul from Vertiv. Scott is the Chief Product and Technology Officer. Scott, how are you today?
I'm doing well. Thank you very much for having me.
Thank you for being here. Scott, I have to admit something. When I saw that we were having a sit-down conversation, I had been really looking forward to this, because what you are doing at Vertiv is solving a really big challenge with AI and infrastructure that I know you know this for many, many years now, but I think the general public is starting to become aware of.
I think that's fair. From a Vertiv perspective, I think we've gone from important to the data center and the AI industry, but relatively unknown to folks who are actually paying attention to who we are and what we do now. Vertiv, we're the power and cooling and overall solutions infrastructure folks from a data center level. We're helping to actually build and fabricate and design the data centers of the future. I would say a lot of the awareness and the industry recognition comes back to some of our performance, our growth, and all of those things, but the partnership with NVIDIA and kind of jointly developing a lot of the things we're talking about, I think has really put us on a map to a lot of folks that weren't previously paying attention to this space or to us in general.
Absolutely. Before we started filming, I know we were speaking about just that, and you mentioned now my neighbors actually know what I do. How do you explain to your neighbors, for example, what does Vertiv solve? What challenges does it solve?
Yeah, so Vertiv, like I said, we're really kind of the critical infrastructure folks. So when we think of powering data centers, we think of cooling data centers, and we think of how we actually deploy and bring up the physical infrastructure of the data center building and all of the interconnective pieces themselves. Like, that is what Vertiv does. We design it, we think through kind of the future state of where products and solutions need to go to enable the AI solutions and the chip architectures that Jensen and the NVIDIA team are talking about. We help as kind of the foundational infrastructure level bring that to reality.
Absolutely. When I was speaking to my mom this morning and sharing about Vertiv, she's like, well, what do they do? And here's how I explained it. Tell me if this is accurate at a very high level. I said, models we use that run, different chatbots that we interact with, they need thousands of GPUs to run. But for those GPUs to run, they need two things effectively, which is power and cooling. And those two things can bring challenges, and basically that is what you are solving.
100%. To query that chatbot, to run that AI inference, to do all of those things that a normal person would interact with AI or candidly any data center, those servers, those chips, those GPUs have to sit somewhere. Mm-hmm. They sit in a data center. That data center has to deliver power to that chip so that it can run, and effectively that chip creates heat. And a lot of the solutions that Vertiv deploys, whether it's liquid cooling or air cooling or other types of approaches, is about removing that heat from the chip, getting it out of the racks, getting it out of the data hall in the building, and figuring out how to get it to the atmosphere, or ideally to figure out ways to reuse it to make all of these data centers we're driving more efficient, more effective, and maybe less impactful to the world as well.
Absolutely. You had some big announcements this week here at GTC. Could you share some of them with me?
Yeah, the biggest announcement I think was the creation of the Omniverse Rubin DSX, our one core solution for that. Really what that means from a Vertiv perspective is an end-to-end pre-designed, prefabricated, converged systems engineering approach to a full data center.
Okay.
So we think of all of the elements of powertrain and thermal chain, the liquid cooling we talked about, the heat rejection of a data center. We have partnered with NVIDIA and others to predefine what all of those interfaces look like, what that site solution ultimately looks like, and to do it in a way that is maybe changing how we would have done data center design previously, in that we're doing it digitally. So within NVIDIA's Omniverse, we're trying to drive towards more physics-based and simulated types of designs to speed up a lot of the converged infrastructure approach, so that long before a shovel ever hits the ground or a construction company is trying to put up a data center, we understand the performance of our gear. We understand how the chips and the clusters and all of the servers working together will perform in that environment, and we can launch that to kind of to the industry or to all of the customers, so that we can help speed deployments and we can help kind of enable us to get time to token a little quicker.
Absolutely, and that's one of the biggest things that comes to mind for me anyways when I think about digital twins, is really how they enable companies to move so much faster now. Do you have any examples, maybe not even specific numbers, but examples of how you've seen using digital twins speed up the process?
Yeah. I think it's critical that digital twins are really an enabler for us to get out of this bespoke, on-site, custom construction world that we've previously lived in to something that is truly more pre-designed and thoughtful around the building blocks that have predefined interfaces and connection points, and how ultimately like our gear needs to be deployed on site in a way that doesn't require kind of the complexity of figuring out after it's already been delivered or after it's already been commissioned. That's really kind of been the name of the game for us, is figuring out an enablement path for us to do it digitally with kind of physics-based capability within the products themselves, so that we know those simulations and those emulations of how the infrastructure will behave are true.
Yeah, exactly. Yeah, I like that. The word thoughtfully, I think that's such a powerful word to describe what digital twins are doing. It's simple, but it's very powerful.
Absolutely.
Scott, when it comes to converged physical infrastructure, how do you explain this topic to folks listening who maybe aren't as familiar with it? It's a lot of big words.
It's potentially a lot of big words and a lot of buzzwords as well. So it's and we hope it's not just corporate speak, but really converged infrastructure is trying to get out of this idea of individual point products that weren't designed together, that were potentially designed by a bunch of independent companies, all trying to come together on site, and it becomes either a consulting engineer's problem, a construction company's problem. Converged infrastructure for us is really about, I'll use the word thoughtfully again, the predefined block sizes, the interface points, the deployment model for that infrastructure. We do it in a digital simulated environment. We do it in a CAD environment so that we can actually see how all of the piece parts will exist in Omniverse or in a digital environment long before it's ever put out into the marketplace. Those key interface points help us to actually design better total solutions as opposed to better point products.
Exactly, total key solutions it really comes down to. When you think about that, the total key solution, we spoke about this a little bit throughout the conversation, but where would you place Vertiv throughout the entire AI infrastructure?
Yeah, in the 5-layer cake analogy that has become so fun to dissect this week, we're the infrastructure layer.
The most important layer.
Is foundational. Now you said it, I didn't, but I will run with that. The most important layer, because it's the foundation of everything that eventually gets built on top. When that foundation is correct, and when that foundation is defined and deployed in a way that is thoughtful and purpose-built, and with these end solutions in mind, it allows us to take that infrastructure layer, pair it with how energy comes into data centers, pair it with kind of a thoughtful and more efficient way in which the DSX deployments need to be run. It allows us to think of the entire chain. And when we think of that entire chain, kind of that purpose-built design, those converged infrastructure points, we can unlock better performance, we can drive faster time to market, we can drive lower overall TCO for the companies we work with in a way that, like, when you think about scaling to gigawatt levels, we can't be fumbling over ourselves and multiple parties and different trades all trying to work at the same time. These converged building blocks and this converged approach to design ideally makes us look and feel a lot more like a factory.
Absolutely, and that's why it's the foundational, aka most important layer, because it really needs to all come together. Scott, how are you seeing, and I know you just kind of gave a few examples of this, but how are you seeing emerging AI workloads and system architectures changing traditional assumptions about power density and cooling in data centers?
Yeah, I think in previous years, data centers candidly didn't really care what the workload was. It was going to run on a CPU-based server. It was going to have a particular heat draw or energy draw, and you didn't really need to know or understand. The difference with AI is it is kind of a unit of compute type of an approach where it's a very optimized for that either performance parameter or for that workload. And we know what it will look like. When we think of kind of the cluster size or a superpod in NVIDIA's nomenclature, we can then back up from those purpose-built pods to what does the powertrain and the infrastructure need to look like to best support that. from a size, an optimization, an efficiency perspective, and we can scale that same analogy and that same approach out to the entire site, so that that site is optimized to work as a single computer.
It's incredible. It's so exciting, the times we're in, and I know, before we were filming again, you're mentioning that you've been with Vertiv for a while now. So getting to see the evolution and to where we are now, what do you think about when we look ahead a little bit? I know this can be a vague question, but when we look ahead a little bit, I need to know. I need to pick your brain. What does it look like when it comes to this stuff?
Yeah, I think we're seeing like compounding acceleration, which is extremely exciting for us. Kind of from our perspective, our engineers, our service folks, we're tied into the direction that GPUs are going. The pace of technology is accelerating. The roadmap that NVIDIA is putting out there for GPUs and performance improvement that is being unlocked is truly mind-blowing. And from our perspective, we're in a race to try to not only keep up with that pace, but we're trying to look multiple GPU generations ahead to say, what are the physics-based problems we're going to need to solve? How do I get this much power into a rack that's 600 megawatts or beyond? How do I scale to a data center site or an AI factory that is a gigawatt in capacity, and work backwards somewhat maniacally to say, all right, here's what the roadmap needs to look like, here's what the development needs to look like, here are our technology investments that are going to be needed for us to make sure that we're not tripping over those physics-based problems, and we're actually able to turn on data centers well in advance of when the GPUs and the clusters will be ready to be deployed there. Absolutely.
I mean, it's easy for me to say, but although these are different challenges that you're identifying and will solve and are solving already, they're exciting ones. Scott, thank you so much for your time today. It was really great to sit down with you and learn more about what Vertiv is doing, especially in partnership with NVIDIA.
Absolutely, it's my pleasure. Thank you.
Thank you. And for those of you tuning in, make sure to go check out more sessions on the GTC catalog.